I'm Sandra Gesing. I'm one of the co-PIs of SGX3, the Center of Excellence for Science Gateways, and this is our monthly webinar. We are very happy to have Christina Koch talking to us, and she will start with more interaction, so I think that will be exciting with some more that you get to know each other a little bit better.
Yeah, thank you, Sandra. I'm Christina, one of the research computing facilitators for the Open Science Pool, and I'm joined by my colleague Shomik Islam today, and a friend of the OSPool, Rob Quick, will also probably be joining at some point, and they'll be able to also answer questions in the chat and maybe make some comments as we go along. So thank you for being here, and I did want to start out with kind of understanding who is here and what your motivation is to come to this webinar. So if folks are willing to put in the Zoom chat your name, where you are, and kind of what brings you here today. I put these two specific options, but you're not limited to these. And that's just, it's kind of nice to know who's here, and sometimes if there's anything specific that we can try to address as we go along based on what brings folks. Okay, so people who are curious about the OSPool, great. We're going to talk a lot about that, so you're in the right place. Interested in HTCondor, okay, very good. All right. Okay, and people from all over too, which is great. Oh, Rob was able to join us. Hi, Rob. Okay, with that, I'll go ahead and get started. So I'm going to kick off with like a very quick overview of kind of an intro to the topic, and then we'll dive deeper into the content in more detail. But to start with, you've all introduced yourselves, so we'll do a quick, who are we? So I'm a member of the OSG Consortium, which provides computational capacity and services to researchers, broadly speaking, at academic nonprofit organizations. And how this is relevant to all of you is, hopefully, is that we provide a place, the Open Science Pool, this service, which provides computational capacity to researchers, and we provide support for using it. So a couple quick questions that people tend to ask about the OSPool. Why use it? So it's a good fit for what we call throughput computing workloads. We'll talk more about that later in the presentation. And it could be used as a computational backend for a science gateway, particularly one that's more computationally focused. Who can use it? So if you want to be a regular user or a gateway operator, you have to be affiliated with a US-based academic nonprofit institution or a US-based project. But if you're in the category of someone who is operating a gateway, then the gateway could be used by anyone. There's no restriction on that. And finally, what does it cost? So there's no fee. You can use the OSPool without proposal or allocation. You can just sign up, get an account, and access the computational capacity. So that's a quick overview of the OSPool. We'll go into more detail about what it is in just a minute. But I also wanted to highlight at the beginning that while we're providing computational capacity in the OSPool, the other aspect of what we can offer to this community is people. So this is the full research facilitation team supporting the OSPool. And I'll share these slides so that you can have the links and everything. And there's a broader team supporting a lot of the infrastructure. And so we have a lot of varying expertise and a commitment to advance access to science, computing for science. And if you walk away from this presentation are like, these people are amazing, I want to learn more and connect with them, there's 2 upcoming opportunities to do that this summer. So we're doing a week-long conference called Throughput Computing 2024 in July, and then summer school in August. And those are both really great events to connect with the community and learn more if you're interested. And I will come back to both of these at the end of the presentation. So don't worry, you'll see this information again before we wrap up. Okay. So that was kind of the big picture, OSPool computational capacity, human and community resources. And so now for the rest of the hour, I'm just going to go through some more detailed information about the OSPool. We'll get a little hands-on experience, and then we'll have some time to talk about specific features or services you might have questions about, hopefully have some discussion. And as we go along, feel free to put questions in the chat. I'm Shomik, my colleague Shomik, will either be able to answer them there or sort of wave his hand and be like, Christina, here's a question you should answer. So that we don't have to wait till the very end to do Q&A. So with that, I've said the word OSPool or Open Science Pool multiple times already. So what exactly is it when we talk about the OSPool? So to tell that story, I'm going to start here, that many of us are at campuses or institutions where there's a local computing cluster, where people wanted to support researchers at that institution. And so they invested in hardware and people and built a cluster. So the question that we've asked is, what if the capacity that's available in these individual clusters could be pooled together? Specifically, if a cluster isn't being at a specific institution, isn't being used 100% all the time, what if some of that leftover capacity could be contributed to sort of this virtual cluster and anybody could use it, not just researchers at that particular institution? So that is what the OSPool is, is all these different institutions who have local resources, who are either dedicating some of them as contributions to this virtual pool, the OSPool, or where it's more opportunistic, where it kind of depends on how much usage they have locally, and that so the amount of available resources they can contribute will change over time. So that's it. And in some ways, then a user's interaction with the OSPool is similar to using a local campus cluster, in that you start on your laptop or your computer, you log into a login node, what we call an access point. And you'll see in a minute that you can do this either via terminal or Jupyter kind of interface on the web. And then you submit jobs. And the scheduler we use is HTCondor. And then those jobs run on the various contributed nodes that we call execution points in the OSPool. So there's some things about this that are different than a typical campus cluster, which we'll get to later. But in the broad level, it's you submit jobs and they run. And it works in a way that's probably familiar to a lot of people on this call. So services that are available to anybody in the US are access to the OSPool. We also run some dedicated access points that anybody can get an account on to use to submit jobs. And alongside the OSPool, there's a network of data caches and origins for delivering data files around this distributed computing environment. So all the little stars here, I think, are, well, I forgot to clip the legend, but pretty sure those are different institutions that are contributing resources to the OSPool. So you can see that there's a lot of different contributors, and they're pretty geographically diverse. So that's kind of fun. So this is an idea of what's possible on the OSPool. You can run an awful lot of jobs if you want to. Move around a lot of files. Again, a little bit more about that later. And at the moment, we're supporting a diversity of fields of science. The bottom graph on the right there is showing the different institutions that people are coming from and the amount of computing they're getting. So one of these could be your gateway in the future. And I will preface this slide by saying this is one of our biggest users. So not everybody is running at this scale, but this is Eric Wright's research group at the University of Pittsburgh. And you can see, I think the number that really boggles my mind from this little clip is the red box of 27 million jobs run in the past year, which is a lot of jobs. So I show this partially because it's kind of fun, but also to start you thinking about, what could I do if I could run 20 million jobs in a year? Do I have a workflow that is expressed in that way? So we want, for people for whom this is a good fit, we want them to be able to scale up, to do more because they have access to a lot of computing. All right. And with gateways, I think there's the added benefit of you could reach whole communities in a more user-friendly way, I think, than a typical job submission interface. and a lot could be accomplished. So that's the big picture. So I'll pause there. I'm gonna kind of talk about sort of ideal use cases and so on for the OSPool before we jump into our hands-on, where we're actually going to submit some jobs. But are there any questions before then about the OSPool generally, or any of the services or terms I just used?
Since you have shown your biggest, one of your biggest users, so did you ever get in that situation that you could not provide resources anymore, that that it went into the backlog so much that it was like, okay, we have
Yeah,
distributed differently, yeah, because that was already
yeah.
impressive. So I thought, yeah.
Yeah, with the limit, I think the limitations are more a little bit what I'll be talking about next, which is like the type of work you have to run. If you need to run for like a week and you have 5 million of those, that's less feasible. So I would take, like, supposing his group's jobs are running for like a day. Well, the hours were there actually, so they're a bit shorter. So I think it's maybe more reasonable to think about what's the total number of hours you need.
Mhm.
And I honestly don't know what the max is. We would love to find out if someone wants to
It's a
really
good
try to.
problem to have, yes, if so many users are on your. There is also a question
Mhm.
in the chat. So
Yeah, can you comment on providers and usage of login nodes? So yeah, so the it's not the OSG, but there's we support 2 or 3 login nodes, and we'll show you the sign up process in a few slides. And anybody at the US institution can get access to those. Those are supported by us. You can just log in and use. It is possible for institutions to run their own access point that connects to and submits jobs to the OSPool. That's obviously more work for you, but sometimes it's advantageous, and in the case of gateways, is sometimes necessary. So I don't know if that totally answers the question, Carl, but if you have a follow-up, let me know. And then the question about how many CPUs storage is available, I'll maybe touch on that in the next set of slides. Okay. So moving forward, so like what can you do on the OSPool? So the classic kind of workload that runs really well on the OSPool is one that's a high throughput computing type workload. And this wouldn't be a presentation given by us if we didn't feature the world's largest cake. But that's because it's a really good description of the kind of workload we're looking for, where you can express it as doing a lot of smaller things to accomplish a bigger task. So in the case of the cakes, everybody can use a normal oven at home, and you get many people to do that. And then you bring the cakes together to make the world's longest cake. We're kind of doing the same thing with computers, where individual jobs can be farmed out to these resources that are being contributed by the different institutions. And then at the end, the researcher will have, a big pile of results that they can use to advance their research. So getting down to more specifics, the ideal OSPool job is one that's about desktop sized. You can still get a lot out of it, but you'll have maybe not quite as many jobs running at once is what I would call like desktop size. And then once you start getting into small server sized or bigger, we're less able to provide a lot of capacity. And that's truly just based on the architecture that I described in the earlier slides. We can't depend on, say, InfiniBand connecting the different nodes because they might be in different places. And we can't always guarantee a certain amount of runtime because the resources are being contributed in an opportunistic way. Data needs to move around because jobs may run in different locations. So a lot of these specifications are based on how the OSPool is designed. But there's definitely some flexibility, and we'll talk about some additional resources a bit later for this right column. In that, I often tell people, if you're sort of in these first two columns in some combination of rows in terms of the cores you need, the wall time you need, the memory, the size of your data, then it's probably worth running on the OSPool, especially if you have lots and lots and lots of jobs to run. So to circle back to the question that was in the chat a minute ago about how many CPUs available, I think it's better to think about how many jobs could you have running at once. And if you're in this first column, you could have 2,000 to 3,000 or more jobs running at one time. If you're in this middle column, maybe closer to high hundreds or 1,000. And in this rightmost column, either nothing if you're like really doing something that's outside the scope of what the OSPool supports, or in the like tens to low hundreds. So I think that's the way we think about what capacity is available. Okay, so two very common use cases of this kind of high throughput computing approach are, one, processing many data files. This encompasses a significant number of domains. Anybody that's working with sequencing data, imaging data of all kinds, biomedical data, like lots of things, text. So this is, we're going to do a docking example in a minute. So we had a user from, I think it was a year and a half ago, who did, something like 40 million docking runs of different molecules and protein ligands related to drug discovery for multiple myeloma. So very classic, good fit problem for us. And then the other second big use case is if you want to run many, many simulations, and that covers, again, a pretty wide range of domains. Anybody doing kind of statistical things, economics, physics, people who want to run a lot of simulations with different parameter settings. So this example on the right is either engineering is the group actually at North Carolina State, where they're basically just running simulations of these colloids that they study with different input parameters and seeing what happens. So putting a finer point on this, this is the gateways that have used the OSPool so far tend to be in this second category. So there's a gateway in development at this link, which we'll try to share in a minute, for the Event Horizon Telescope, doing simulation work around black holes, because that's what they're looking for. I will share this link. It's really fun to watch this video because it kind of shows really well how just wanting to do larger combinations of parameters can really explode the number of things you want to run, which is a great use case for us. And then class 12, this is a physics experiment that's based at the Jefferson Lab. I think they don't have a public facing gateway, but they have an internal one that makes it really easy to submit a bunch of these event simulations. That's part of their work. So Rob, do you have anything you want to say really quickly about this gateway?
Not that you haven't said. We have been developing this for the last year. We are doing our first production run this week, so we will do about 6,000 images at different parameters. You can see the A spin that is located at the -0.94 and the -0.5, et cetera, down there. So we're doing that at several different values and on about, again, 6,000 files. So it is underway, and we should have that open and usable by the researchers. We're going to do one sample run here, production run up front to see if we run into any problems, but we're hoping within a few weeks of doing that sample run that we hand this over to the researchers and they can start at least submitting from the gateway. Interacting with the output, we're working on the gateway opening up a Python notebook so they can have more flexibility when dealing with the output. There's not just a single type analysis they do. Once they get the output, they want to do many type of things, and so we'll hand over a Jupyter notebook at that point because each researcher will have a different type process that they'll want to run on the data, but the execution will be fully through a gateway environment.
Yeah, thanks, Rob. This is very exciting. Okay, so there's use cases. So hopefully that helps people. I think many of you came in and were kind of curious about the OSPool in general, but I always want people to think about like that recognition of like, oh, maybe that would be a good fit for the OSPool, like this problem or this community or whatever they want to run. So hopefully those examples are helpful for that. Last quick thing before the demo, because it relates how we're going to get to the demo hands-on component. How do you actually get access? It's a simple process. You go to this website form, fill it out. We can add the link in the chat if you need it. We have a quick orientation meeting with you to discuss your use case, what the OSPool is about, how to get started, finish creating your account, and that's it. Then you can use it. If that's too much of a process, you can actually get started with kind of test driving our environment right away. We have this OSPool Notebooks Jupyter-based environment where if you've never talked to us, you can just click on that link, authenticate, and or log in with CI logon, and it spins up a temporary access point with a kind of Jupyter-based front end, and you can submit jobs to a little mini test pool. If you have a full account with us when you go through the login process, then it just connects you to the full like supported access point, and when you submit jobs, they go and run in the OSPool. So I bring that up because we are going to use the notebooks to connect. Mona, what's your question?
Yeah. So if I want to submit jobs and I have things I want to run, I presume I have to put my code onto those machines, or how does?
Yes.
Okay.
Yes. So you would have to. Slides are not. Yeah. So in that sense, it's very well, yes and no. Okay. If in that way, it's very similar to like using a normal cluster. You need to upload your code and the pieces, the components that you want to use to run the job. It's not strictly necessary to have everything available at the after the hands-on. We'll go briefly over some solutions that exist for data handling where you could access data remotely. But in general, I think you can use the mental model of a local cluster where you typically put things on the login node in your home directory, and that's how you run jobs.
Okay.
What about support for containers?
Okay, that's coming. So maybe actually what we'll do, I'm just looking at time here. We support containers, basically is the short answer. Let's kind of walk through this sample workload, and then I'll answer the question about containers. We can talk a little more about data, and I'll address the question here about how contributing institutions justify sort of their participation, because I think that's a great question. So that link is a little messier than I liked that I put into the chat, but if everyone could go to, if you'd like to follow along, go to notebook.ospool.osg.htc.org, which is a real mouthful. And you can click the sign on with CI logon button, pick either your institutional ID or org ID or GitHub. All of them should work if things go well. And then it should open up the screen you see on the bottom right, where you can pick a server option. We're just going to use the basic one. And then once that's set up, you can open a terminal and run this command. Vino, just to get a sense for kind of what the interface is like. So I'm gonna do this. Hopefully it's gonna work. Otherwise, it's gonna be a very short demo. So let me new share. Here I am. I'm gonna use, because my real ID is associated with an access point, so we're just gonna use the GitHub basic start. This is the moment of truth. So this is, I'll be stepping through this demo, and folks can follow along if you want, or you can just watch if you would rather not. Okay, can I have a, if you are trying the demo, please do like a thumbs up or the green check mark if it's working for you, just so we know that people are able to connect. Okay, great. While we're waiting, question, will the data persist? This is a great question. So if you're using this guest instance, so you see here, if I have open a terminal, hopefully, there we go. I'm this generic Jovian user. So this is the guest access. This will not persist between sessions. It maybe persist for like an hour, but don't plan on it. If you have a full account, so I have a full account with my Madison ID. So if I had authenticated with my Madison ID, this would then show my account on the access point, which is like permanent and is there and persistent. Servers select the basic one is fine. It actually doesn't really matter, but basic is sufficient. So that's that. And if you want to load the tutorial, that's the command. Should hopefully find everything out. Yeah, so there's a great question here. How much data can be loaded on the access point? There's default quotas. At some point, if you're working with a lot of data or larger data, we'd want to talk about using the Open Science Data Federation or an external source like S3 or even providers like Box and Google Drive for fetching and moving data. So having an account, sorry, I'm not being very clear about my language here. If you have contacted us to get an OSPool account using one of your existing identities and you log in using that identity, then what you see on the screen would look different. If you logged in via access and that access identity is not associated with an OSPool account that we manage, then you should just be in the guest setup. Okay, so in the tutorial folder, once you've downloaded it, there's a notebook README. I'm going to click on and open that. And part of the reason for this demo is so that you can come back and look at this in more detail later. But this is a pretty simple docking workflow where you have some kind of molecule, some kind of protein, and you want to see how they potentially could fit together or dock. And we're using the program AutoDock Vina. So the files that you'll see, so this gets back to the question of what needs to be uploaded on the access point, are these kind of README files. There's a submit file, which we'll look at in more detail. There's a script to actually run Vina. And then there's some data. And the data here are just the files representing the ligand, the receptor, and a config file with some information about how we want to run Vina. So there's a description of what they are. We're going to go ahead and download Vina specifically from the GitHub, the official GitHub with releases. So you can evaluate the cells in the notebook either by clicking play or typing Shift Enter. So I'm going to do that for this one, and it's going to download this release and save it under the name Vina. So this just appeared right here on the left. And so now I have everything I need to run my job. I have the data in this folder, and I have the actual Vina binary or program. And so I'm going to make it executable and run the help command to confirm that it works, and it does. So that's all great. So we're ready to set up our job workflow. So the first thing we're going to have is a submit file. So this is an HTCondor submit file. It's going to list the executable. This is an area where Condor submission is a little different than Slurm, where you bundle together what I would call the job metadata and the actual commands you want to run. So in Condor, those are separate files. So there's a script that we'll look at in a minute called vinarun.sh. It actually has the commands we want to run. It's its own file. We indicate which of these files that are present on the access point we need to run our job. So that includes all the contents of the data folder and the Vina program. We're going to save standard out, standard error, logging information, and then request the resources that we want for this particular job. 1 core, 1 gigabyte of memory, 0.5 gigabyte of disk. So they're little files. And then the Vina script is really simple. It just runs the command on our inputs and produces an output. So with that, we're going to run condor submit, which is the submit command with the submit file. And that'll put job in the queue. And then you can run a condor queue to see what it's up to. You can also, this runs better in the terminal. It does weird things in the notebook. You can also run condor _watch _queue to get a little bit more of like a interactive updating progress bar kind of thing. So I think, again, the reason I wanted to do this tutorial is not to get too hung up on the details of the implementation. That's something that after this training, you could go through this example again, go through some of our other tutorials, and look up, exactly how Condor job submission works. What I really want to convey is, this is a very good throughput computing example. And starting to think about what components do you need to think about when submitting a job. And so I've been trying to highlight, the input files, what resources you need, and what that looks like. So it's done. Hooray. Hopefully. I can get it to exit. Yeah, there we go. And what you'll see is, you'll see it in the left as well, this receptor ligand output file that has the results of the docking run. So in the interest of time, I'm not going to go through the second piece, which talks about how you might scale this up for more jobs. But you're welcome to kind of look through it and kind of see how we start incorporating how we want to organize files. This idea that data originates in one place and might come back to a different place, which might be useful if you're trying to set up a workflow where users are like uploading a set of data files and then you want to create a folder of outputs for them to use. So in answer to the question, does this docking job rely on InfiniBand? Not at all. So if we go back to the submit file, which is somewhere in the middle here, we're just requesting 1 core per job. And the assumption here is always that each job is running on the resources available on a single node. Never multiple nodes at once. So again, very much like laptop size, desktop size calculations are the ideal, although we can sometimes support things that are a little bigger. Okay. Questions about this example? There.
So Christina, I will say, especially with Autodoc Vina, I did a project called Splinter many years ago that did a huge runs of these Autodoc Vina and to the size of about 19 million jobs, and it ran in less than a week. So this is something that you can really scale up on if you have this type of workflow. So just a sample there that you showed one job, but we did, many millions of these with the potential drug treatments along with their proteins.
Yeah, thanks, Rob. Mona.
My question is, if I want to use this for a Science Gateway, so the account then I should create for the Science Gateway to use would be probably like a community account, right?
Right, you would use a service account.
Okay.
Yeah. So yeah, with that, I'm going to actually move into the sort of services and features. So a lot of the nuts and bolts questions that y'all have been asking about. But I will circle back to the question in the chat. How typical is this example, say, needing only 1 core? So typical, most jobs running in the OSPool probably use 1 core. There's a huge amount of science that can be run in this way. Some of the examples from the previous slides, physics, statistics, things like docking. The individual jobs are not computationally intensive. They just have a lot of them. But I think it's more thinking about, like, what are you trying to do? Can it be shaped in this sort of many jobs that need 1 to 12 cores each? Then it's a good fit for the OSPool. Because there's definitely people that run like 4 core, 8 core types of jobs as well. Okay. So a review. Some of these questions came up when I was introducing the OSPool. So because resources are distributed, the computers are a little bit everywhere in the OSPool. There's some implications for how we run work. You can submit and run thousands of jobs, as Rob just alluded to. It is possible that jobs will get run somewhere else, but there is the possibility of that happening. Resources can come and go. Ooh, I might be coming and going. My internet connection says it's unstable. So this gets back to the question of like how many CPUs are available at any one time. You know, it will change. But generally speaking, there's enough of them running that there's sort of thousands of cores available. And Shoma could maybe even run Condor status right now on the OSPool. We could see what's available at the moment. The OSPool can also respond to pressure. So sometimes if you put more jobs in the queue, then more resources are acquired or brought into the pool so that it grows. So it's hard to say. GPUs similarly, at the moment, at one point we regularly had about like 60 GPUs in the pool, but again, things come and go. With pressure, more might appear. So that's just something to be aware of. And then I think implied, but perhaps not stated in my previous slides, there's no shared file system in this. And this is probably the area where, in some ways, we are the most different from a typical campus cluster. And so we think a lot about data movement, data stage in and stage out options, which I'll touch on in a minute, and software portability, because again, no shared file system means we don't have a stock set of modules ready to go. So we used, like we just did in the Vina example, where you can just download and run something, but we also really, I think, are moving more and more towards recommending containers as a nice, stable solution for a lot of people. Okay, and then there was a question I wanted to. Yeah, okay. So, some other tools, features to think about. So we just submitted jobs with HTCondor. Condor has a lot of features that make it easy to submit many jobs at once. So that's one reason we use it. It just has a lot of features. You can automate things. You can checkpoint things that run for a long time. There's tools like Dagman and Pegasus that allow you to run multi-step workloads. And perhaps of more relevance to people who might be interested in automating job submission via, say, a gateway, there's the command line interface that we use. I think it's helpful to start with, to be familiar with. But there's also a Python API so that you can fully script both job submission and things like monitoring log files to see whether a job is complete, for example. So that's all functionality that comes through using HTCondor as the scheduler on the system. In terms of software that you can run on the OSPool, most Linux things can be run on the OSPool. The main restriction we find is like licensing. You know, if you have to check out a license from a license server, both practically, that's challenging in a distributed environment, and philosophically is going to limit the number of jobs you have running. So you won't get the full benefit of the OSPool experience anyway, if you have a limited number of licenses. But beyond that, we've run all sorts of different things. We provide container support mainly via Singularity. So you can either use a like native Singularity image or convert a Docker image to Singularity and just pop it into the submit file, actually. So I know we have some examples, maybe the FastQC tutorial, where it's just an option in the job submit file. You set the container name and then it's invoked on your behalf. You don't have to run Singularity or Apptainer yourself. And oops, data. So this is the piece I wanted to make sure we got to. Condor has a whole set of file transfer plugins that can be used to fetch data from various sources and put data back into various sources. And so on our access points that we operate, users get a 50 GB home directory, and that data can just be transferred to and from where the job executes via the submit file. Users also get, I think, a 500 GB space in the Open Science Data Federation. And and data can be fetched and put into that location, also via options in the submit file. And then if you have external resources, there's submit file options to use those to fetch data to a job, running job, and potentially push output back. I didn't emphasize this, but in the job submit file, there's an option for request disk. That's how you choose how much space you want for an individual job's working directory, wherever it lands and runs. So that's something that you control. So it's a little bit of a different mindset. It's a little bit more cloud-like, I would say, in terms of how data is accessed and used. But there's a lot of options. So the question that's in the chat, how long would it take me to upload a 1 terabyte seismic survey data set? So it depends how good the network is between us and the OSDF like origin space you'd be using. Basically what Shomek just put. Another possibility, the OSDF is built, the Open Science Data Federation is built in this underlying tool or technology called Pelican. And we are very close to basically releasing and training on the option of starting your own origin on top of your data where it is and having that join the existing Open Science Data Federation, so you don't have to move it anywhere. So you just start the origin process, join the federation, and then your jobs could access the data directly via that origin wherever they run. So we are going to be giving a training about this at PERC for sure, and potentially at the Throughput Computing conference I mentioned. So that's something, stay tuned. We'll definitely announce about some of those things on like the CARC and Campus Champions list. So yeah. So you wouldn't be mounting your local network attached storage. You would be running a service on top of it that would federate your data into our data federation and be able to access. And the syntax looks a lot like a URL where it would be able to fetch the data from the service you're running. So hopefully that answers the question. Happy to talk later if you can stick around. Mona.
Yeah, since you're open almost to anyone in the US, I'm curious about what type of sort of security restrictions you may have to protect yourself and also the resources.
Yeah, so there's a security team that does kind of exercises and reviews of the system. This is part of the reason we meet with everybody who applies for an account. We're restricted to people at US institutions. We try to confirm with PIs of students before we create accounts. So there's a lot of, I would say, personal checks and balances in the system. So we do probably similar things that you would do, that any campus would do in giving access to people on their cluster. But so yeah, this is one of the times where sometimes it's helpful to think of this as it's a strangely shaped cluster, but a cluster nonetheless. And the main thing we're concerned about is because some universities, everybody in the university gets an account on the cluster, and then they can use it. So we don't have that guardrail of like who belongs to the university because we're available to a lot of people. So that's where we do the academic affiliation and meet with people before we approve their account.
Okay, aside from sort of the human guardrails, I mean, I suppose, there could be a student that, or someone knowingly or unknowingly running things that would trash the cluster.
Yeah.
have?
Yeah, we have some configuration in place, like things like if you use more memory than you request, your job will be killed and put on hold. So those kinds of things are possible. We have reports. I can't speak to the more like specific security practices because that's less of my experience. But there is like some monitoring that happens in terms of like practical impacts. Like we get reports and like, oh, okay, we should follow up with this user and make sure, you know, they know what they're doing.
Okay, thanks.
But yeah, it's not been a huge problem to this point. I mean, it's I would say it's no different than the kinds of things that happen on anybody's cluster
Mhm.
periodically. So
Great. Okay.
yeah.
Thanks.
All right. So that's the data side of things. One last quick thing, if you've listened to this and you're like, oh, the OSPool sounds almost like what I want, but I think I need like a little bit more cores, or my data is a little too big, or whatever. We are running a separate pool called the Path Facility. The restriction here is that you have to have NSF funding, so it's not quite as open as the Open Science Pool, but it also has a little more features and functionality. So if this is something where you're like, oh, we have this grant to build this gateway and it's with the NSF and you want to apply for credits and access, please talk to us. We'd be happy to chat more about that. And so this gets to circles back to a question that was asked at the beginning of this section. To actually have a gateway set up, it's a little more work than just getting an account. You either need a service account with us or your own setting up your own access point, or both. We're happy to engage with this, provide support. You know, we're on Slack, all these things. But that's just a heads up that the OSPool machinery is all there and ready to use, and you can test drive it as a user pretty easily. As not gateway providers ourselves, we can provide limited support for the sort of website stack side of things. And that's where folks at SGX3 would probably be a great resource. They're the right people to contact about these things. Okay, so to wrap up, because I know we're almost at time, ways to connect with us. I mentioned, slides, are the Throughput Computing Conference that is happening in July. It's a great time. It's in Madison. Come and join us if that sounds interesting to you. Whoop, nope. There we go. Our summer school is coming up in August. It's really about application to real workloads. So if you or researchers in your space are interested, please have them apply. Applications are open now. That's also in Madison, also a very good time. Highly recommend. Costs are covered. So travel, hotel, attendance, all covered. Just come and learn about throughput computing and apply it to your work. We also do user office hours twice a week and a like campus meetup once a week. The campus meetup would be an appropriate place to come and ask gateway questions, I feel. So we do topics on the first and third week of the month, and on the other weeks of the month, we do just open discussion. So if you wanted to stop by and bring your questions, that's a great place to do so. And we have all our sort of usual trainings, documentation, tutorials, recordings. Again, I'll share the slides so that folks can have access to these links. And yeah, I'll leave this up and circle back. Yeah, show Mick.
Christina, Carl has a question.
Yeah, so reactions from contributors to share. So we'll probably have some of them speaking at Throughput Computing. And this goes back to the question of how do you communicate about this to leadership, like why contribute? A lot of people contributing have CC Star grants, where one of the stipulations of the grant was to contribute, some % of the capacity back to a national initiative. Didn't have to be the Open Science Pool, but several grantees chose that route. So I would say from my experience, I feel like people are interested in contributing, in participating, in like not just building something up locally, but sort of then engaging with the broader community. That's a primary motivation for why to contribute and what it brings. You can like see what projects you've supported on your capacity, which is kind of fun. I think there's yeah. So that's the quick answer.